So now that we've seen that we can have variables, things that we change their value rather through the running of our programs. And now that we've seen what it is that we can name them, the way that we can legally identify a variable with its variable name in C++, we can finally start talking about some of our cardinal, so our included data types. Now, the integer data type is the easiest way for me to do this. This is also 2.6, by the way, and this starts on page 43. The easiest way for me to get this across to you is to say that an integer is a whole number. It does not have representation past the decimal value. So what does that mean for you? I am clicking here on page 44, and this is table 2-6, the integer data types. Now, there's more than one kind of integer. For us, for this class, really, we're just going to stick to the plain, simple int integer. But you can see here on page 44, table 2-6, that we have other more specific integer data types. The short int is only 2 bytes long, so it's very, very concise. It's a very, very small reference in our memory. You can see there minus 32,768 to plus 32,767. We have to account for the 0, hence the off by 1 there. So integers are plus or minus numbers. The unsigned short int, not a negative number. Integer 4 bytes. So you can see that that's already going to be twice the storage requirement of a short int, but at 4 bytes, that's really going to be just fine. So negative 2 billion and change to positive 2 billion and change, so on and so forth. I'm going to let you read through that. I know that you're okay with whole numbers, so let me just add this concern that we have when we're dealing with integer values. So what happens if I enter 2.5? What happens to the decimal precision, the .5 that happens after the 2? Now, some of you are going to be familiar with rounding, where we look at 2.5 and we say, well, it has to be a whole number. So I'm going to use the rounding that I know how to do, and I'm going to take that 2.5 and I'm going to round it up to 3. It's a good instinct, but it is wrong. With the precision, so the decimal precision, so what happens after that dot in an integer, it's simply truncated. 2.5 is 2. We lose all of that decimal precision that happens there. This is potentially a problem. Now, it could be that it's not going to be a problem, but if we think about things like your bank accounts, a bank account balance is not a good integer data type, because if I have $1.47 in my account balance, really I only have $1. That 47 cents does not round up, does not round down. It is simply truncated. It disappears. And there's no way to receive or to recover rather that 47 cents. So those are gone forever. So the truncation here is an issue that you have to be aware of. An integer is a whole number, and a whole number only. There is no decimal precision. You need to account for that.